All right, so this sort of problem is a little bit different than the stuff you've seen above. Yes, you definitely need to find the dy dx by implicitly deriving this equation and then solving for dy dx or y prime. But then the problem asks you to find d squared y dx squared. That is the second derivative. So the cool thing is, once you find the first derivative and then solve for y prime, all you need to do is derive it again. So that's how this works out. Once you find the derivative, you just derive it a second time. Sometimes it's a little bit more complicated than that because you might have to implicitly derive it a second time, but it's usually not too terribly difficult. Okay, so let's give this one a go. Derive both sides implicitly. Oh, but we first have to put some parentheses around our y's, just so it reminds us to use the chain rule. All right, so deriving this, derive the first term, that's just 2x. Derive the second term, power rule mixed with the chain rule. So the 2 comes down in front, subtract 1 from the exponent. So you have 2y to the first, or just 2y. And then you multiply by the derivative of the inside, which is y prime, because y is a function of x. Okay? Then, for the third term here, we have minus 4. Then the right-hand side is just 0 because derivative of 0 is 0. All right, so now the goal is to get y prime by itself. So I'll remove all the extraneous information and then subtract over everything that does not have a y prime attached to it. So this is all technically y prime stuff, so we're going to leave that on the left-hand side. Everything else is going to get subtracted over. So we take away the 2x and then add the 4 to both sides. So rewriting our work here, after we do a little bit of cancellation, this gives us 2y, y prime, is equal to minus 2x plus 4. So far, so good. All right, so then what we're going to do is we're going to divide over our 2y to get y prime by itself. All right, and then what this gives us is y prime is equal to minus 2x plus 4 all over 2y. Awesome, so that's the first derivative. Now we need to find the second derivative. We have the first derivative, so all we need to do is derive this thing implicitly again. But in order to do that, this is going to require the quotient rule because we have a function in x on the top of this thing and on the bottom, in the numerator and denominator. So to this end, we need to derive this thing separately using the quotient rule. All right, so derive the top. This gives us minus 2. Leave the bottom alone, times 2y. Subtract, leave the top alone, derive the bottom. What's the derivative of the bottom in this case? Be very careful. In this case, it's going to be 2y prime. All right, so that derives this using the quotient rule almost. We still have to divide by the square of our denominator. And then this is equal to d squared y dx squared, or the second derivative, because we derived both sides. So if you derive y prime, you get y double prime. So this is the same thing as this. All right, are we done though? Well, we want this in terms of y and x only, and notice that we have a y prime here. We don't really need to solve for this y prime in this case. In fact, we're given this y prime. We are told that y prime is equal to this lovely thing I just circled. So you substitute that in. So every place you see y prime, you substitute it in with what you know about y prime. So what is this actually equal to? Minus 4, simplifying the first term, y, minus 2x plus 4 times 2 y prime, which is going to be minus 2x plus 4 over 2y, because that's equal to our y prime. And then this entire thing is over 4y squared, using exponent rules. That's all there. Okay. So technically speaking, you've done what you were asked to do. You could simplify this a little bit and try to find common denominators and all that good stuff, but in all honesty, I would stop here because you've done what you were asked. So the rest is just algebra. We'll leave it at that.